Welcome everyone to Advent of Code 2022, Day 5. So we're not doing any preamble today, we're getting straight in. Let's look at Day 5, Supply Stacks. So for this problem, the elves are unloading the ship to continue the expedition. So basically they have a big old crane, and the crane is rearranging stacks of crates that are on the ship. They need to be rearranged to, get some stuff off properly. And yeah, your job is basically to follow through all of the moves that they're making, and at the end of it, you need to get some sequence out of it at the end. So when I was first reading this problem, I was kind of thinking that they were going to make us figure out the best pattern to move stuff in, which can be a bit of a nightmare, but it's actually a little bit simpler than that. Effectively, all they're asking you to do is they're giving you a state, which is you're given the state of all the stacks of the crates that are on the ship, and then you're given a list of moves that they need to make with the crates. When you do that, at the end of it, what they want you to do is they want you to extract which crate is on the top of each one. So this is how they show you what your initial state is. So this is your stacks. There's 3 stacks here, and they've got, each stack has a crate in it. Each crate has a letter on it. So what they want you to do is they want you then to use this sequence of moves to rearrange the crates on the stack, and then at the very end they want you to extract which crate is on top of which stack, and then you end up with like a code at the end, which is what your results should be. So when you first look at this, the first part, it feels like it's probably a difficult problem to solve. It's actually not a difficult problem to solve, but this whole messing with setting up your crate is a little bit of a pain. So I was toying with this. This happens occasionally with these problems where, say, you're given an input file and there might be multiple passes that you would have to do on the file to extract everything. So you have to read the file in a couple of different modes to extract all of the information from it. But realistically, the information that changes frequently is this list of moves. So for your sample here, there's only 4 moves, but for your input file, there's, like 100 or 1,000 moves or something like that. Well, there's a lot anyway. So what you really want to do is you want to just do all the moves, and the state, like, you can just hard code the state. It's not very big, so you can hard code the initial state, and then all you're doing is reading in all the moves and modifying your state based on the moves, and from that you can get your answer. And the actual code to do that is really very simple. So with that said, let's have a look at my solution. So these are my states. You notice I have this one commented out, which is just the sample state. So in my little CLI that I developed to make this easy to run, you'll see I can specify whether I want it to be the input or the sample. That's not how you spell sample. And what that does is that will flick which input file gets read. Because in this case I don't have that, I've actually just hard coded them and just comment out the one that I want to run. I could wire it up to be able to pick them. I just haven't done that. I might do that because it could come up again where you have to also change the piece of code based on this, or how I've chosen to solve it anyway. So we'll just run this for the input. There we go. There's a sequence of letters coming out. Runs very fast. And yeah, this is my input sequence hard coded in. So the way I've done this, I've started, if you were to just rotate these around, these are the stacks. So there's just a normal array. The front of the array is the bottom of the stack. So the end of the array is essentially the top of the stack in this case. And yeah, that's about it. I was able to copy paste those in and just did some string formatting stuff in this to give me the right order and everything. And these are my stacks basically. So once you have the stack set up, the actual solution is really, really simple to part 1. All I'm doing is reading each file. You remember each line of the file. For me, I've just made my input file just be the move commands. Do some splitting to get, there's basically 3 numbers that you want out of each one. So you want the number of crates to move, you want the index of where they move from to where they move to, So there's just those 3 indexes you need. Because I've used a hash here, those indexes are nice and easy for the from and to portions. And then also a 2D array would also do this. And then also the number to move is that first argument. So when we have our split set up here, we look at this. This is a loop that'll just go for that number of times. So if it's 2 crates to be moved, this loop will execute 2 times, and it'll pop a crate from this array. So the pop function for an array in Ruby will just remove the last element from that array and return it. So this now is, say if it's the first one here we're looking at, it popped p off, it'll return to this variable. And then this line, the double arrow operator just throws it to the end of another one. So because we know what that index is, say if it pops it off 1, it's going to move it to 2, it'll just stick p at the end of that. And it'll do this in a loop for however many boxes, your crates you want to move. And that's it. To get to the very end then, I just go loop through my states. So this will just loop through each of these. And then grab the last character from each one, join them all together to form one string, and then output it, and that's it. So this is pretty straightforward. Not a super difficult problem once you break this part down to know that, okay, I just need to create a state map. It's really easy then from there. So then for part 2, they, similar to yesterday, they don't really up the complexity at all. They just change slightly what the problem statement is, and it's actually still very straightforward. So there's one key part in this that I actually overlooked originally, and I kind of just made an assumption on it. Where is it? Yeah, here we go. Crates are moved one at a time. So that is that if you're trying to move a bunch of crates off of this, say from 1 to 3, you take this crate off, move it over, and then you take this crate off and move it over on top. So that would have the effect of flipping the order of those crates. I kind of just assumed that was what was happening, and until I scanned this and found, oh, that is actually what's happening. So it was just kind of lucky that my solution worked straight away for that. But it could be a different way, and that's classically the kind of thing that can slip you up in these problems, that you just make an assumption, and that completely screws you over. One thing to note is that they're very prescriptive in these problems. You have to read every single word of the problem, because often, if there was an assumption like that could be made, they will have called it out somewhere, but it's not always obvious where it is. So in this case, it's a simple line here, which you could just gloss over. Now, they do a pretty good job of highlighting the key text pieces, one at a time. But still, when you're scanning these problems, it's very, very easy just to gloss straight over them, especially if you're busy trying to do it under time pressure. And also there's reams and reams of text here, which can be hard to go through sometimes. So that's just something to note on this. Anyway, moving on to part 2 of this, they basically say that, okay, instead of it being 1 crate at a time, it's now a block of crates at a time, can all be lifted up and moved all at once, which essentially just has the effect that it doesn't flip the order anymore. So all you have to do is you have to go through, know how many crates you want to take off the top. You need to remove them from one stack and dump them onto another, which is not a difficult thing to do at all. So let's skip on to my part 2 code, and it's almost identical to my part 1 code. There's just one subtle difference here. So in the part 1 code, where I take the loop for number of times, I assign a single crate to that, and then I shift it over onto the top of the other stack of crates. Instead, what I'm doing is I create a little array of the crates, which are the ones that are going to be moved. In my times loop, I unshift, so I pop the crate off the top of the stack where it's moving from. I unshift it into this crates to move. So unshift in Ruby, instead of adding to the end of an array, will add to the top of the array. So effectively this crates stack, or this crates array, becomes the top section that's been removed off of another array. So then once this exits, I just append that onto the target stack that it's going to, and that just dumps onto the end of it. That's it. That's the only difference. Pretty straightforward. Again, the exact same logic at the end, which just loops over it, finds the last one, joins them all together, and gives you your output string. And yeah, that's it. Simple as you like. Also runs in about the same time, because the logic is it's essentially the exact same thing. It just slightly changed the method by which you do it. So if you had your code set up logically very simply, the same way I did, you can just plug in those changes, in which case it makes it very similar to how yesterday went. Didn't really add much complexity. So that is it for day 5. Hope you guys are having fun. I'm having fun. And yeah, I will see you all tomorrow for day 6.